Good morning and welcome to this hour's discussion. Today we want to look at a question that relates directly to one of the things we began yesterday to discuss. And without wasting much of time, we are given a question this way. Say if the number of observations is 31, the mean of that number of observations is 3, and the sum of squares of that observation is what is 504. That we should find the variance s squared. So for us to be able to find a solution to this question, we first of all will be able to recall for ourselves, the formula for variance of a sample of observations. And do remember that the formula for variance of sample observations when variance or when frequencies are not involved is given as we have that s squared, which is variance, is given as 1 all over n sum, we open a bracket, x minus what? X bar all squared. This is the formula for variance of a sample of observations when frequencies are not involved. So we are going to look at this question and then look at the information given to us in this question to be able to know whether the formula we have will be able to handle the problem. Looking at this formula now, we can see the n here, which is n here. We can see x bar here and we can see x bar here. Unfortunately, we cannot see sum of x squared now from this formula. So what we are going to do is to recall another variation of this formula. Variation in the sense that all of them are going to arrive at the same answer. So we recall another variation of this formula that may possibly contain everything which we are given in this question. And another variation of this formula is given as, we have s what squared is given as 1 all over what? N, you open a bracket, sum of x what squared minus n of x bar all squared, you close up the brackets. Of course, one of these days we are going to show how this formula is exactly this formula. And even if you can make reference to the class we had yesterday, you'll be able to see clearly without stress on how this formula is exactly this formula. So looking at this formula now and then looking at the information given to us now, we can see that we have n here and look at the n here. We have x bar here and look at the x bar here. And we have sum of x squared and look at the sum of x squared here. So instead of making use of the first formula, we are going to make use of this formula in order to obtain the variance. And then let me call this formula up here now. The formula says, so a way of solution, we have the formula to be that s squared now is given as 1 all over what? N, we open a bracket, sum of x was squared minus what? N of x bar all squared. We close up the brackets. So what we are going to do is now to quickly substitute into this, and this thing becomes, my n is 31, so I have 1 all over what? 31. Then I'll open a bracket. This my sum of s squared now is given as 504, so I have 5 what? 04 minus. My n is what? 31, so I have 30 what? 1 multiplied by. My x bar is given to me as 3, but the x bar is squared, so I'm going to square 3. So I have 3 raised to power 2. I will close the brackets. So this thing becomes 1 all over 30 what? 1. You open a bracket. Here becomes 4 minus. Here is now 30 what? 1 multiplied by what? 9. So you have something like this. So the moment you open this thing now, you will be able now to evaluate with ease the value of the variance. And another thing we want to point out quickly, of course, anybody can evaluate this without stress. Another thing we want to show in this class is how questions can be asked to us in another way, making use of the same formula of what? Of variance. Now, you know quite alright that we can make sum of s squared here subject of formula. If you want to make this in subject of formula sum of x bar squared now, what you are going to do here becomes, you now write this formula this way as a way of solution. You write this in to be that x squared now is given as, you open a bracket, sum of x squared minus, you have what, n of x bar all squared, you close up the bracket, all over n. This and this are the same thing. So for convenience, you can say all over 1 and you cross multiply. This n multiplied by s squared will give you that this becomes what? N s what squared is given as everything we have here, which is sum of x what all squared minus what? N of x bar all squared. Your effort is to make sum of x squared to stand as subject of formula. So I'll call up everything that is here to this left-hand side and equate it to this one. So this becomes sum of x all squared minus n of x bar all squared. This becomes what? N s what squared. You have to retain this one at the left-hand side because that is where your interest is, and you take this quantity over to the other side. So you have that therefore that sum of x what all squared is now given as what? N s what squared plus we have n x bar all squared. So by implication, somebody can give you number of observations, give you the variance of the observations, and then give you the mean of the observation, and require you now to find the sum of square of the observations. Somebody can do a thing like that. You can even have an interest where your interest is to make n subject of formula, where you are given variance, you are given so many things, you are asked to find the value of what? Of n. In that case, what you are going to do here is what? You have n here, you have n here, you factor n out. So factoring n out here, what you have here becomes what? N, you open a bracket, s squared plus what? X bar all squared, you close the bracket. This will be given as sum of x all squared. Making n to stand alone, here, you are going to divide both sides with this. So you have all over, open a bracket, s squared plus x bar all squared, close it, all over, open a bracket, s squared plus what? X bar all squared, close the bracket. This will cancel this. And you are left that n is given as sum of s squared all over the variance plus x bar squared will be able to give you the number of the observations, which of course, if it gives you something in decimal places, you are going to approximate to the nearest whole number. You see how questions can come to you in the variance which you think you know and you are familiar with. And if you forget to call up the variations of the formula of variance which you know, you may not be able to quickly tackle the question. So keep connected to us as we continue to bring questions like this before you and continue to show you how to trash these questions now effortlessly, as long as you will be able now to recall the formula we are going to provide to you. Thank you very much and stay connected till our next class.